call you up in the middle. Okay, so let's talk some more about rainwater and rainwater catchment. So here is a spreadsheet that I have been working on to try and help me understand how much water we need to catch and how much square footage of artificial impervious material, whatever the permits call for. However they phrase it, to where if you can capture rainwater off of some a non-natural surface. So let's take a look through this. Gallons per inch of rainfall per square foot. That is how many inches, nope, that's the wrong one. How many gallons per inch of rain per square foot? And this was actually a little bit tricky to find. A lot of these are like, how many gallons of water will fall on a roof of 2,000 square feet, blah, blah, blah. I'm like, I just give me the base number to go with. So this particular website here says 0.6 gallons per square foot. Some other thing that I found earlier got a little more accurate with 0.623. So the average number of inches of rain per year, that comes from this chart here. And we can see the average precipitation in inches. That says 13. The average snowfall in inches is 36. So if we say, okay, how many inches of snow equals 1 inch of rain? About 13. So if we have 36 divided by 13 is like 3 is 26. So it's like 3. It's about 3-ish. So 13.41 plus 3-ish is about 16. Let's call it 15. Let's call it 15 and be careful. Let's drop this to 0.6. Let's just be as conservative as we can there and give it as much padding as we want. So current yearly units and then gallons per unit. So this comes from our actual water consumption history. So this is on our water bill. They give us this handy dandy little chart here. And it tells us how many water units we've consumed, which seems weird. One consumption unit is equal to 748 gallons. And so if we add all this up, it equals 82, but we can do it here real quick. We got 10 plus 4 plus 4 plus 5 plus 5 plus 4 plus 6 plus 6 plus, what is that? 9 plus 6 plus 9 plus, what the heck happened in September? Why do we use so much water in September? That's when our toilet was running, and I have since had to go through and replace all the seals. 82, okay. So we come back to this, and we've got 82 units at 748 gallons per unit. So our current water usage per year is vaguely 61,336 gallons. So our square footage needed is C7, our total water usage, divided by C1 times C2. So C1 times C2 is basically our gallons collected per square foot per year. And then we take the total gallons that we use per year divided by that number. So that gives us 6,816 square feet for kind of our insane water usage. I think that's really, really high. So then I've gone through and researched a bunch of different options for just basically what can I lay on the ground, capture water, and direct it. So similar to the previous test where I just had a tarp laying on the ground, like what is the cheapest, what's the cheapest thing I can do to just lay it down and start collecting water. I can build, collect it off of roofs and with gutters and all that stuff later on when we finally have, buildings up there. But in the meantime, how can I just get something up there that'll be collecting water? In looking at asphalt panels, galvanized steel, all of this other stuff, here's kind of a breakdown of the length and width of the item, the price per item, price per square footage of that item, and then the total cost of that. Oh, you can't see the total cost on the total cost over there. Okay. So I was looking through a bunch of different options here. And then while I was on Craigslist, I came across this dome fabric that's for sale. I've actually ordered a roll of it. So this is 105 inches times 1,000 feet of this dome fabric. It's the same stuff that is used on the Denver airport. So that's pretty awesome. If it's good enough for the roof of the Denver airport, I think it's good enough for me. one of the structures that I'm looking at is building a geodesic dome or geodesic tunnels or something up there. And I've always been fascinated by this like architectural fabric type stuff. So to be able to like kind of play around with that is going to be awesome. But this is obviously way more than I need to build like a dozen domes, more than so. Using it also as rainwater just rolling a bunch of taking a bunch of it and just rolling it out on the ground and collecting water with it sounds awesome to me. So that is by far our cheapest option. That's down here, so we can see the price per square foot of this stuff is 34 cents, where everything else is significantly more expensive. And what's interesting is the reason that this stuff is so cheap is it's on this repurposed materials website, which I found recently, where they sell all kinds of like weird stuff. They actually even have a section called weird stuff. Oh yeah, weird stuff up here. And so they got it because somebody ordered it. In whatever I was looking at, it said that the reason that it's for sale here is that it's not Brady compliant, because it's made in France, and whoever originally bought it for their project had to have stuff that was Brady compliant, which means that it has to be all completely made in the USA. So somebody misordered this stuff from France and then couldn't use it because it wasn't made in the US. So I'll use it. It's giving a good home to something that otherwise couldn't because of regulations. So that's it should be on the way in the next couple weeks. But so that is clearly our cheapest option there, with a total cost of less than the whole roll, because I don't even need to use the whole roll for it. And then whatever is left over I can use for geodesic structures, I suppose. Okay, so now we've gotten through all of this, except for in the last video we took a look at my little rainwater catchment system, and that was pretty much like a 16 by 20 tarp. It was just laid out on the ground, 20, so 16 times 20 is 320 square feet. I captured maybe 50 gallons. So that would be 50 gallons divided by 320 square feet means that I captured far less than what you would expect from 1 inch of rain. So clearly my system had overflowed in multiple points, which we saw in the video during the test, like it overflowed. So I really need to make sure that any water that is captured into the system and goes down to the catchment tank gets to the catchment tank and doesn't overflow in whatever filter or whatever. So that's clearly something that I really need to work on. Okay, the square foot that we're looking for here is 6,816. Here is a map of the property, and if we take a look here, and maybe you saw this in the previous videos, we've got these giant like rock patches. So there's like nothing in them except a big pile of rocks. It looks like it used to be like it was part of like a lava flow previously. Like I have no idea what this geologic structure is, but there's nothing growing on it. So why not capture water that lands on this? I don't know. Maybe if you're a geo water catchment person, you could tell me why that might be a bad idea. But the way I see it, that water probably just lands on these black hot rocks and then quickly evaporates. So that's going to be my assumption. I'm happy to be proved wrong. Or these are fairly large. Like even if it doesn't necessarily look like it, I climbed up this one, and I might have a video of that I can insert in here. Maybe not. Maybe I'll just cut this whole part out. Also, what did I do with my water? I set that down somewhere. Anyway, so these are big areas, and so let's take a look. What were we just looking at? We were saying we need 6,000, let's just call it 7,000 square feet. What's 200 square feet among friends? Okay. If we take this and say we need like 7,000 square feet, let's like add a line here. And let's just say, how big is this? I mean, obviously rolling out this stuff up here is not gonna be easy. It's gonna be a pretty big challenge getting it up there and rolling it out. Okay, so this polygon here, that's 1 acre. 1 acre, 2 square feet is 43,000, and we needed what? We needed 6. So there's plenty of space, plenty, more than enough space to do rainwater catchment for all of our needs. We just have to make sure that we've got the, tanks or pond area or whatever to do that. And as I mentioned in the last video, we can see that there's like, well, you can't see here. If I go to the base, change the base map to, I think it's, is it that one? No, that one. Okay, so like this is a ridge and this is a valley and here's a ridge and then here's like a valley. So like right here in this area, maybe we can like build in a little dip. Wow, I am really like, my color's really blown out. Okay. We might be able to put up like a little dam here and start capturing water in this, put a cistern down here. One of the permaculture principles is obviously to keep water as high up in the land as you can and then allow it to gravity feed down, blah, blah, blah. And yes, we want to do that eventually, but for right now, I just want to make sure that we can collect enough water to sustain our general usage. So 61,000 gallons seems like a whole lot, and maybe that's really, really overkill. It's kind of hard to say. I think his name's Joe from Homesteadonomics. Homesteadonomics. He says that he has about 11,000 gallons in his system. Andy Man has this very large 28,000 gallon cistern. And then in this tour of his entire property, it looks like he has maybe 40,000 gallons. And then in the Green Dream project, they built this awesome 14,000 gallon cistern themselves. And it looks like they've got some extra poly tanks that might be 2,500 gallons each. I'm not, maybe that's wrong. So maybe 15 to 20,000. So it looks like my 60,000 gallon estimate there might be way overkill. So we'll look at the feasibility of capturing that much water in another video, but I still feel like 50,000 gallons would be a comfortable target to aim for because we might have more than just us up there. And also, obviously, our usage right now is clearly, we're using flush toilets. I take showers and shave my head that take forever. So we could definitely do something to really decrease the amount of water that we use. And obviously up on this property, we're going to do that. We're going to definitely have systems in place and change our habits in a way that we're going to use a lot less water. So that's a lot of the theory, craft, whatever, min-maxing number, figuring out dishness that I've been doing around the rainwater catchment. So any other questions about that, feel free to let me know. But this is about what we're shooting for, just to make sure that I'm repeating myself. Cool. Thanks for watching. Bye-bye.